Bismillahirrahmanirrahim. I am Muhammad Ahsan Irshad, group number 3. These are the members of group 3, and our topics is vector atom model and orbital angular momentum. Vector atom model. Vector atom model is an extension of the Bohr Sommerfeld atom model. Sommerfeld atom model. It could not explain the fine structure of spectral lines. It could not explain the distribution and arrangement of electrons in atoms. It could not explain Zeeman effect and Stark effect. To overcome all these objections, a new model known as vector atom model was proposed. The two distinct features of the vector atom model are: the first one is the concept of spectral quantization, or the quantization of direction. The second one is the concept of spinning electron. Spectral quantization. According to Bohr's theory, the orbits are quantized as regards their magnitude, their size, and form only. But according to quantum theory, the direction and orientation of electron orbits in space also should be quantized. To specify the orientation of orbit in space, we need a fixed reference axis. The reference line is chosen as the direction of an external magnetic field that is applied to the atom. The different parameter orientations of electron orbit are determined by the fact that the projections of the quantized orbits on the field direction must themselves be quantized. Second is spinning electron. Spinning electrons, the electron spins about an axis of its own while it moves around the nucleus of the atom in its orbits. In other words, the electron is endowed with a spinning motion and an orbital motion. According to the quantum theory, the spin of the electron also should be quantized in a new quantum number called the spin quantum numbers. Spin quantum numbers denoted by S is introduced. The spin endows the electron with a spin angular momentum Sn and a spin magnetic moment. Means the total angular momentum of an atom should be the vector sum of the orbital angular momentum and spin angular momentum. Quantum numbers associated with their atom models. The there are seven quantum numbers. Number one is the principal quantum numbers is represented by the sign n. Uh, the second is the orbital quantum number. This is represented with L. The third is the spin quantum number. It's denoted by S. The total angular fourth is the total angular momentum quantum number. It's denoted by J. Magnetic orbital quantum numbers. This is represented by ML. And six is magnetic spin quantum number, and this is represented denoted by ms. The seventh and last is the magnetic total angular momentum quantum number, and is denoted by mj. So first is the principal quantum number. The serial number of the shells starting from the innermost is designated as its principal quantum number. It's represented by n. It can take only integral values excluded zeros. N is equal to 1, 2, 3, and so on. The second is the orbital quantum number. It's denoted by L. This quantum number defines the shape of the orbital occupied by the electron and the orbital angular momentum of the electron. This may take any integral values 0, 1, 2, 3, and n minus 1. This thus, if n is equal to 4, L can I can take the four values 0, 1, 2, 3. By convenience, by convention, an electron for which L is equal to 0 is called S electron. If L is equal to 1, is called P electron. Uh, if L is equal to 3, D electron, and etc. The orbital angular momentum PL of the electron is given by PL is equal to Ln. The third one is the spin quantum number. It's denoted by S. This has only one value. S is equal to 1 over 2. This the spin angular momentum Ps is equal to Sn, where S is equal to half. According to the wave mechanics, Ps is equal to S plus into S plus 1 and multiply by half n times. Since electron can spin clockwise or anti-clockwise, S has two values, positive half and negative half. The two values, two electrons with the same sign of spinning quantum number are said to be parallel, are said to have parallel spins. Two electrons with opposite sign of spin quantum number are said to have opposite spins or paired up signs. The fourth is the total angular momentum quantum number. It's denoted with J. It represents the total angular momentum of the electron. It is the sum of the orbital angular momentum and spin angular momentum. The vector J is denoted by the equation J is equal to L plus S with the restriction that J is positive. The spin angular momentum S is equal to positive or negative, and J is equal to L plus S plus sign where S is parallel to L, and negative sign which represent where S is anti-parallel to L. The fifth is a magnetic orbital quantum number is denoted by ML. The objection of the projection of the orbital quantum number L on the magnetic field direction is called the magnetic orbital quantum number. The possible values of ML are ML, L minus 1, L minus 2, and 0, M minus 1, minus 2, and minus L. ML may have any of the 2L plus 1 values from minus L to plus L, including 0. We can find magnetic orbital quantum numbers by this expression 2L plus 1. If we know about L. The sixth one is magnetic spin quantum number. It's denoted by MS. This is the projection of the spin electron s along the direction of the magnetic field. The spin angular momentum can may assume only two possible positions with respect to the magnetic field. It may be parallel or to it or anti-parallel. MS magnetic spin quantum number have only two can have only two values, positive half or negative half. The last one and seven is magnetic total angular momentum quantum number. It's denoted with mj. This is the projection of total angular momentum j on the direction of the magnetic field. J can have only odd half integrals values like as j is equal to L plus half, positive half, and j is equal to L minus half. Hence, mj can magnetic total angular momentum quantum number have only uh, 2j plus 1 values from plus j to minus j, 0 excluded. And the second our topic is the orbital angular momentum. First we know about what is angular momentum. Angular momentum is a vector quantity that represents the product of body's rotational inertia and rotational velocity. Rotational inertia we measured in radians and the rotational velocity in seconds about a particular axis. Formula L is equal to L cross LW is R multiply R cross the cross product between rotational inertia and the rotational velocity. Units kg m square per second. ml2 t l square t minus 1. The next is our orbital angular momentum. Electrons have two types of rotational motion: orbital angular momentum and spin. Orbital angular momentum is a property of the electron's rotational motion that is related to the shape of its orbital. The orbital is the origin around the nucleus where the electron will be found if deduction is undertaken. Orbital angular momentum is also called extrinsic angular momentum and the azimuthal quantum number. Formulas mv is r is equal to n h over 2 by l h over 2 pi. Quantization of the orbital angular momentum in physics. In quantum physics, orbital angular momentum is quantized. It can take only two on only two certain whole number values and cannot take values in between these. It is not a continuous property, but it is treated as having discrete values, not a continuous values. Quantum numbers. Orbital angular momentum is one of the electrons quantum number or key properties. When orbital angular quantum is thought of as being a quantum number, it is called the azimuthal quantum number. And the next is significance of orbital angular momentum. In physics, angular momentum uh, is the rotational equivalent of linear momentum, like Rayleigh momentum of momentum moment of momentum or rotational momentum. It is an important quantity in physics because it is conserved quantity and the total angular momentum of closed system remains constant. Um, Now we discuss example orbital angular momentum of the moon. We can use the angular momentum calculation for circular motion to evaluate the angular momentum of the moon relative to the earth. We take the radius between earth and the moon is 3.84 10 raised to power 8, and t is equal to 2.36 10 raised to power 6 s, and m is equal to 7.35 multiplied by 10 raised to power 22 kg. The speed of motion moon in its orbit is given by we can find the speed of moon in its orbits by v is equal to 2 pi r over t. First we will find the speed of the moon, and then we will find the linear momentum of the moon has a magnitude m by expression p is equal to mv, and we put and get 7.50 multiplied by 10 raised to power 25 kg meter per second. The next we will find the angular momentum, therefore has a magnitude L is equal to rp. We put the values of r and p. So we will get 2.88 multiplied by 10 raised to power 34 kg meter square per second. And according to the right hand rule, it is directed out of the page. Figure is represented here. This is correspond to a direction toward the North Pole star relative to the solar system. Vector atom model for the orbital angular momentum. The orbital angular momentum for an atomic model can be visualized in terms of a vector model where the angular momentum vector is seen as processing about a direction in space. The diagram shows that the possible values for the magnetic quantum number m is j is ml for f, ml for l is equal to can take the values m is equal to ml is equal to minus 1 minus 2 minus 1 0 minus 2 or in general ml is equal to minus m minus l plus 1 and so on l. Thank you.